Here are your solutions to 3-7 guided practice problems. In problem number 1, we are being asked to solve each system of equations and do so by graphing. So the first thing we're going to do is plot y equals x plus 3. We can do that by putting a point at the y-intercept, which is 3, and then our slope is 1, so we know that we're going to rise 1 and run 1. Which only gets us to this point here, so we're going to work in the opposite direction by going left and down and continue to plot points by going left and down at one at a time until we get to this point here. And then we're going to draw our straight line, and of course lastly we need to label this equation y equals x plus 3. Then we're going to take a look at the other equation, and we're going to graph it by starting out at our y-intercept of -3. Our slope is -2 over 1, so we're going to drop 2 and over 1. And again, we can go in the opposite direction by doing the opposite. Move as many points away as possible, and then ultimately draw a nice straight line. And lastly, label that line as y equals -2x minus 3. Now you can clearly see that we have a solution right here, and that point is -2 and +1, and that is the solution to our equation. Now let's take a look at problem number 2. Our equation here is y minus 6 equals 2x, which is not an equation that we can easily graph, so we're going to do some algebra here in order to put it into a format that makes it easier. And of course the problem is right here with the y minus 6. The way to take care of that is to add 6 to both sides of the equation. And our new equation in slope-intercept form is y equals, here's a zero pair, remember, y equals 2x plus 6. So now we can go to 6 on the y-axis, our slope of 2 over 1 puts a point here, and another point here and here. Okay, now we can draw a line connecting all the points, and lastly label that. Okay, the next thing we need to do is take a look at our other equation, y equals 2 times the quantity x plus 1 plus 4, and plot that. Again, we have some algebra to do here. Y equals 2 times x plus 1. 2 times x, distribute that as 2x, and distribute the 2 over the 1, and we get plus 2, and then we've got another addition of 4 here. And then the last thing we can do is combine like terms here. We have y equals 2x plus 6. And you'll notice that once we do the math, we actually have the same equation, so we can label this line both y equals -6, y minus 6 equals 2x, and also y equals 2 times the quantity x plus 1 plus 4. It is the same line, so the answer to our problem in this case is infinite solutions. Problem number 3. The sum of Sally's age plus twice Tomas's age is 12. So we can do a couple of things here. First of all, we're going to record is 12 as equals 12, Tomas's age as x, and Sally's age as y. So our equation is going to be the sum of Sally's age, that would be y, and sum would be addition, and twice Tomas's age would be 2x. So we have y plus 2x equals 12 for our first equation. For our second equation, we have the difference of Sally's age, y, and Tomas's age, x, so y minus x is 3, so it equals 3. So we have two equations that we can graph here. We'll start out with the first equation here, and we have y plus 2x equals 12. So the first thing we need to do is get this in slope-intercept form. We can subtract 2x from both sides to do that, and we'll end up with y equals -2x plus 12. Put our point at the y-intercept of 12, and from that point we're going to rise a -2, so drop down 2, and then over 1. So down 2 over 1. Notice that our scales are equal. We are counting by 2 on the y-axis and the x-axis, so we can just use the boxes in order to get where we need to go. And then lastly, draw our nice straight arrow through all of our data, and that would be this equation here. Now we will plot this equation. We have y minus x equals 3. We want to move the x to the other side of the equation, so we're going to add x to both sides. And we have y equals x plus 3. There's our zero pair. So we start out at 3 on the y-axis, and we have a slope of rise of 1, run of 1. So we have a nice 45-degree angle, so we can just move up here. Notice we're going to be always in the halfway between the two lines when we are graphing this, so maintain that all the way up to here. Do the same thing coming down this way, and we end up right here. Draw our nice straight line through all the data points, and that would be this equation here for that line. Now lastly, we need to find our solution, which is the intersection. And you can see that we are right here on the x-axis and right here on the y-axis. So our point is going to be 3 on the x-axis and 6 on the y-axis. So our solution is 3, 6. So they asked us to write and solve a system of equations. Here's our two equations we wrote. We solved it by graphing them right over here, and our solution is 3, 6. And the last thing it asks us to do is interpret the solution. Well, what the solution means is this. Remember, we showed Sally's age to be our y-coordinate, so Sally's age is 6. This stands for Sally's age. And then our x-coordinate was Tomas's age, which is right here, which is the 3. So this is Tomas's age. Problem number 4. A system of equations consists of two lines. One line passes through these 2 points, and the other line passes through these 2 points. Let's find the slope of the blue points first. So we have y2, which is 1, minus y1, which is 3. That's the change in y over the change in x, which is 0, x2 minus x1. So minus a negative 1 would be like adding 1. So we take and do the math. We have negative 2 over 1. So the slope of the blue line is negative 2. Then we can do the math for the red line. Again, we have change in y, 2 minus 4, over change in x, 0 minus 1. 2 minus 4 would be a negative 2, and 0 minus 1 is a negative 1. Again, we have a negative divided by a negative, so we should simplify that to the slope of 2. So we have a slope here of 2, and on our previous one we had a slope of negative 2. So we have a different slope, and we can go back to our original equation, our original points, and see that we have y-intercepts in both of these cases. We have a y-intercept on the first line at 1, and we have a y-intercept on the second line at 2. So we have two different slopes, and we have two different y-intercepts. Therefore, we must have one solution. Remember, that's all they were asking us to do, is answer the question, are we looking at this system of equations? Are we looking for an infinite number of solutions, one solution, or no solution at all? And because they have different slopes and different intercepts, we know that that is one solution. Lastly, question number 5, building on your essential question. How can you use a graph to solve a system of equations? And really, that's quite simple. You use a coordinate plane, and you graph one of those equations, and then graph another of those equations. And if they're parallel, you will have no solutions. If they are the same line, you have infinite solutions. And if they intersect just once, you can find that solution at the intersection.